Hello everyone, welcome back to the another session in Design and Analysis of Algorithms, Unit 1, Topic 5. This video we are going to understand about recurrence relations. In this video, we will trace the recursion function and how to find the recurrence relation and how to solve a recurrence relation. So we'll take some example to understand the same. So this is one function. What is the primary job of this function is, it takes n value. If the n value is greater 0, it displays the n value and it will call test of n minus 1 function. Now this is what recursive function. If n value is equal to 0 or lesser 0, it doesn't do anything. It will come out of the if block. This is what actually a normal function. Now I'm calling this function, let us assume I'm calling this function by passing 5, value 5. So let's construct the tracing tree. I'm taking test 5. So I'm calling the function with 5 value. So it will comes to here, right? 5 is greater than 0. When 5 is greater than 0, condition true, and it will get inside. What it will do inside? It will display the value, n value as it is. And it call n minus 1, which is test of 4. Now again, so again function calls, right, with test 4. 4 greater 0. Now this time again 4 value will get displayed and test of 3 function will get called. Now this time test of 3 is called with 3 value. Test 3 is what? 3 will get displayed and test 2 will get called. Now the same, test 2 is what? 2 will get displayed and test 1 will get called. Now this time 1 is what? N value. So n value is 1 and which is greater 0. So again 1 will get displayed and test 1 minus 1 which is test 0. Now condition 0 greater 0 is fail. When it is fail, it will not enter inside, it will come out of the block. So nothing will get performed over here when test value is 0 or when parameter is 0. Now, what is the time complexity of this function? The time complexity is dependent upon number of calls of this function. So how many times this function is getting executed? Printf will take 1 unit of time to execute. But this test function will take how many times? That will calculate over here. 1, 2, 3, 4, 5, 6. N value is 5 but the calls are 6. That means n plus 1. And this 5, 4, 3, 2, 1 will take n times. Okay. Now, so what is the time complexity of this? Function f of n is n plus 1. This is what the number of calls which is taken by this function. So the time complexity of f of n is equal to what? Order of n. Or you can also represent it as big O of n or the omega of n or theta of n. So this is what the time complexity depending upon the number of calls through a recursive tree or through a tracing tree. Now let's see about recursive relation, how to find and how to solve. So let's go back to the previous example. Now in this example, assume that t of n, I'm representing the recursive function or recurrence relation with the t of n. T of n is equal to what? The time which is taken by this instructions. It takes 1 unit of time, it takes 1 unit of time, it takes n minus 1. T of n minus 1. If test of n is required T of n, test of n minus 1 will require T of n minus 1. So the total time complexity of this is T of n is equal to T of n minus 1 plus 2. 1 plus 1, 2. So this 2 is what? A constant time. So I am taking here it is 1 because 1 represents it's a constant time. So the recursive relation is T of n is equal to, if n greater 0, then T of n minus 1 plus 1. If n equal to 0, it doesn't do anything, but I cannot tell 0 time is required because some time it will take, right? So I'm taking as constant time which is 1. So what is this called as? Recurrence relation. Okay. Now, so we'll use back substitution method to find out the recursive, to solve the recurrence relation. So that is what is the recurrence relation? T of n is equal to T of n minus 1 plus 1. If you know T of n minus 1 value, then only we will be knowing T of n value. Now, using back substitution method, T of n is equal to T of n minus 1 plus 1. Now find out what is T of n minus 1. Substitution method. Wherever n you found, there you substitute n minus 1. So that means n minus 1 plus 1. That means T of n minus 2 plus 2 plus 1. So this is what T of n minus 1 value, and substitute this value over here. So that is T of n is equal to T of n minus 2 plus 1, and this one as it is plus 1. That is T of n is equal to T of n minus 2 plus 2. If it is T of n minus 2 value, it becomes T of n minus 3 plus 3. If you take a constant time, then that will be T of n is equal to T of n minus k plus k. T of n is equal to T of n minus k plus k, right? Now assume that n minus k is reached to 0, that is n is equal to k. Now T of n is equal to T of n minus n plus n, where T of 0 plus n. T of 0 we know from the recurrence relation, which is 1 plus n. T of 0 value is 1 and n is as it is. So finally T of n is equal to 1 plus n. The same n plus 1 times as we got from the recursive tree or tracing tree, right? Now what is the time complexity of this, or to which class it belongs among our time complexity classes? It is what, or big O of n. The same you can also represent with theta of n. The class is what? Linear class. So this is what one example. So we'll take other example also, and this time we'll take the different function. So where the different function is what? Here when if n greater than is 0, then we'll take some for loop over here. For I is equal to 0, I less than n, I plus plus. We'll now find out a recurrence relation for decreasing function. So when loop executes, then we will be doing some printf statement, then we will be calling recursive call. Now we'll see what is the time complexity of this. The total time complexity of this function is indicated with T of n, and it takes 1 unit of time. So for loop will take n plus 1 unit of time, and this statement will take n times, right? And this will take T of n minus 1 times. The total time complexity is what? T of n is equal to T of n minus 1 plus 2n plus 2. So what is the time complexity of these two? The time complexity of these two is what? It belongs to linear class. That means we will represent with big O of n. So that is, this will be represented as with n. So now what is that relation? T of n is equal to T of n minus 1 plus n when n value is greater 0. When it is lesser 0, again it is a constant time. So that is, we'll easy to write the same. 1 is equal to 0 and T of n minus 1 plus n is greater 0. So this is what recurrence relation. Now we'll solve this recurrence relation. So that is what? We'll take some recursive tree or tracing tree. I'm calling some n function. Now what is the job of n function? It is displaying n value, and it is calling n minus 1 value. The same, when I'm calling n minus 1, it displays n minus 1, it calls n minus 2. The same, n minus 2 displays, n minus 3 will get called. So once it will reach to T of 2, that means what? It will be displaying 1 and it is calling T of 1. It is displaying 2 and it will be calling T of 1. The same, it is 1 and T of 0. 0 means nothing, right? Now, what is the time complexity? T of n will take n time, n minus 1 time, n minus 2 time, n minus 3 time, 2 time, 1 time and 0 time. So now add all these things to get the complexity, which is 0 plus 1 plus 2 plus 3 plus n minus 1 plus n. Now what is this? The series n is n into n plus 1 by 2, sum of natural numbers. The time complexity of t of n is equal to n into n plus 1 by 2, and that is of theta of n square. So this is what the time complexity which is required for this function. Now we'll use back substitution method or induction method to find out the recurrence relation for the same. That is, t of n is equal to t of n minus 1 plus n. Assume that it is first equation. Now what is t of n? T of n is what? Substituting n minus 1, correct? Now if you substitute here t of n minus 2 plus n minus 1 plus n, correct? Now t of n minus 1 means substitute here in this t of n minus 1 plus n minus 1. That means you'll get t of n minus 2 plus n minus 1. What is this value of t of n minus 1? So I substituted as it is and the n as it is. Right? Now t of n is equal to t of n minus 2 value also you have to substitute. That means t of n minus 3 plus n minus 2 as it is value plus n minus 1 plus n. And if you take k times, that will be t of n is equal to t of n minus k plus t of n minus k plus n minus k minus 1 plus n minus k minus 2 plus n minus 1 plus n. So assume that it reaches to n minus k, that means n minus k is equal to 0. It reaches to 0. So hence n is equal to k. Now substitute k in the place of n. That means t of n minus n plus t of n minus n plus 1 plus t of n minus n plus 2. Now this is what the series. Now t of 0 plus t of 1 plus t of 2 plus t of 3 dash dash t of n minus 1 plus n. Now t of 0, you know the value from the recurrence relation, which is 1. And look at this, it is a series. That is what sum of natural numbers, that is n into n plus 1 by 2. So this 1 will be taken as what? Constant. So finally it takes n square, the time complexity. Thank you all.